Today we're going to talk about one of the coolest puzzles in the tech world. How does a tiny little app or website grow up to become a global giant? We're going to follow the entire journey, from a single server, maybe in someone's garage, all the way to a massive system that serves millions of people every single day.
You've totally seen this happen, right? You find some cool new app, and it's super fast. Then a month later, everyone's using it, but it's still just as fast. How on earth do they pull that off? How do they avoid a total meltdown when their traffic just explodes? Well, that's exactly what we're going to unpack.
You know, every huge tech company has a baby picture, and for a web service, it usually looks just like this. It's so simple. A user makes a request to mysite.com. That request hits one single web server. That server then turns around and talks to one single database to get or save info, and then, boom, it sends the page right back to the user.
And for a little while, this is just beautiful. It's so easy to manage, it's cheap to run, and hey, it works. But this nice, peaceful setup, well, it has a very short shelf life, because success is coming, and success brings a whole lot of traffic with it. And then, this happens, the thing you've been dreaming of. Your site gets popular. Thousands of people all try to use it at the same time. And that one little server, it just can't keep up. It gets totally overwhelmed, and the whole system just grinds to a halt. Your website is down.
So let's be really clear about this. A single server has two, well, fatal flaws. First, the obvious one. It gets swamped by users. But the second one is actually way more dangerous. It's what we call a single point of failure. That means if that one box has any kind of problem, hardware glitch, a bad line of code, anything, your entire site is offline for everyone. Not good.
So the first big fix is actually pretty brilliant. We bring in a load balancer. The best way to think about this is like a digital traffic cop. Instead of all the cars trying to jam onto one tiny road, the traffic cop is there, intelligently pointing each car to one of many open lanes. It just spreads the work out nice and even.
Now, this brings up a really important concept: how you actually add more power. You've got two main choices. You could take your one server and just make it a giant, super expensive beast. That's called vertical scaling. Or you could just add more normal, cheaper servers to the group. That's horizontal scaling. For the huge websites we all use, horizontal is almost always the way to go. It's way more flexible, it's cheaper, and you get rid of that single point of failure problem.
Okay, awesome. We've solved the traffic problem. Our site is stable now. But the second you solve one problem, another one pops up. This new bottleneck is all about the laws of physics. Distance. What happens when your servers are in California, but your users in Germany?
That delay just from the sheer distance the data has to travel, that's called latency, and it makes your site feel slow. I mean, look at this. A request might take 120 milliseconds to cross the ocean. That doesn't sound like much, but it adds up and makes things feel sluggish. But check out that bottom path. Using a CDN, we cut that time in half. Getting data physically closer to the user is everything.
And this brings us to the next hero of our story, the Content Delivery Network, or CDN. So what is it? A CDN is basically a whole bunch of mini servers scattered all over the globe. Think of them like local warehouses for your website's heaviest stuff. All the images, the videos, the big files. They store copies so they're right around the corner from your users.
So how does this magic work? Let's walk through it. Say user A in Paris requests a photo. The local CDN server in Paris doesn't have it yet. No problem. It zips over to your main server, grabs the photo, and saves a copy for itself. Then it delivers it to user A. A few seconds later, user B, also in Paris, asks for the same photo. Bam! It's delivered instantly from that local Paris server. No long trip needed.
And the result is, well, it's a game changer. By spreading your content out all over the world, you slash that latency. Your site just feels snappy and responsive for everybody, no matter where they are. And as a bonus, it takes a huge load off your main servers too. It's a win-win.
Okay, things are looking pretty good. We've solved for traffic, we've solved for distance, our web servers are happy, but all of them are still hammering away at that one single database. And you can probably guess what's happening. The database is starting to sweat. It is our new bottleneck.
The solution for this is a cool trick called replication. Basically, we just make a bunch of copies of the database. We pick one to be the master. The master is the only one allowed to handle writes, changing or adding data. All the other copies, the slaves, handle the reads. And since most websites do way more reading than writing, this strategy spreads the database work out beautifully.
So let's just pause for a second and look at how far we've come. Our system looks completely different now. We've got a CDN for speed, a load balancer for traffic, a whole bunch of web servers, and now a replicated database. This setup gives us what's called a stateless web tier. That's just a fancy way of saying any web server can handle any user's request, which means we can add or remove servers anytime we want.
Our system is getting seriously robust. But let's think bigger, more paranoid. What if something catastrophic happens? I mean, a massive power outage, a flood, something that takes out the entire building where all our servers are living.
Well, for the true giants of the web, the answer is you don't put all your eggs in one basket. You build multiple data centers in totally different locations. Check out this diagram. If that whole data center on the left just goes offline, the system is smart enough to automatically reroute 100% of the traffic over to the healthy one on the right. It's an amazing safety.
We have built an incredibly tough system, but there is one final, absolutely massive challenge. Even with all our copies and replicas, our main master database is still a single point of truth. What happens when you have to store data for hundreds of millions of people? There is a physical limit to how huge and how fast a single database can possibly be.
This is where we get to the really advanced stuff. The technique is called sharding. The idea is, instead of trying to build one impossibly giant database, you just break it up into a bunch of smaller, faster, more manageable pieces called shards. So for example, all the users whose names start with A through M might live on shard 1, and everyone from N through Z lives on shard 2. Each shard is its own little high-speed database.
And here it is, the whole shebang, the culmination of our entire journey. This is what a system built for truly massive global scale really looks like. Yeah, it's complex, but every single piece you see here was added to solve a very specific problem that we hit along the way. So when we look closer at this final picture, we see our sharded databases, which are key. But we also see some new things, like message queues and workers. These are basically systems for handling slow background jobs, like sending an email or processing a video, so the user doesn't have to wait. And holding all of this together is a huge collection of tools for monitoring everything, which is absolutely critical when your system gets this big.
You know, if there's one single thing to take away from all this, it's this right here. Scaling a website isn't some project you do once. It's a never-ending cycle. You grow, you find the next weakest link in the chain, and then you engineer a clever way to strengthen it. You fix traffic, then you find a distance problem. You fix distance, then you find a data problem. It just keeps going.
So, we've gone from one little server to this global, sharded, multi-data center beast. It's an amazing piece of engineering designed for insane scale and resilience. But the internet and technology, they never stand still. So the real question is, as we head towards billions of users and apps that are even more complex, what's the next bottleneck going to be?